Assalamualaikum warahmatullahi wabarakatuh, and peace be upon you. So today we are from Group 1 going to present about Lab 2 subject Electromagnetic Compatibility. Group member consists of Duru Zahira, Darul Anwar, and Yazid.
So I will introduce about this lab. First of all, conductor emission refer to electromagnetic interference that travel through cable or electrical circuit, usually caused by current or voltage noise electronic device. It can affect power quality and must control it according to EMC standards. For the radiated emission, on the other hand, is electromagnetic energy released into the air, which can interfere with nearby devices such as radio or Wi-Fi system. Therefore, proper testing and control are essential to ensure all equipment meet EMC standard and operates without interference.
Lab objective: get a good understanding of the effect of the electromagnetic interference due to radiated and conducted emission. So for this experiment, our first objective is familiarize trigger setting of oscilloscope. So this is important. We can accurately check the electrical signal of the wave that occurs suddenly and quickly. The next is we will analyze radiated emission to electrical spark discharge. So this spark causes strong interference and can spread through the air, interfering with other electronic equipment. And we also learn about the understanding EMC standard for electrical equipment. These standards are set to ensure that each of the equipment electrical operates safely and does not cause interference to other devices around it. And lastly is the investigate conductor emission to electrostatic discharge, ESD. So this test is important because ESD often occur in daily life. For the example, when human touch electronic equipment, so it can affect the performance and safety of this equipment.
Okay, so equipment on this lab, obviously we use oscilloscope, which model is Tetronic TDS201C, T-junction, drive coaxial cable circuit, fast feed buffer, and then we use a cable RG58 coaxial cable, 20 meter, and then plate antenna, and then 14 kilovolts ignition called electrical spark discharge radiated source.
So before we start about the result in our activity in this lab is, we must to make sure we will understand details about the conductor and the radiated emission in the real life. The radiated emission, electrical interference that come from electronic equipment and travel through the air. So for this part, we can understand every electrical appliance actually emits some electromagnetic wave. So to make sure of this part is, we must to make sure the wave must be at a safe level lah. So as not to interference with other equipment itself. So the first point is, every appliance emit electromagnetic wave, but there are still safe limits. So we test in this activity, we see the wave emitted by the equipment were too strong or still within the allow limits, and test using a metal plate to capture wave from a 50 kilovolt ignition current spark discharge. So what we use in this activity, we use the radiation source and the secondly is the metal plate of the function to capture the wave the waveform, and the thirdly is the voltage reading and graph change according to the distance. So for this part is during we will do the test, we found that the reading will increase. The reading will increase at the different positions, and if the plate plate and the radiation source with the increase, so the waveform will be decreased. And lastly, it ensure that equipment does not interference with the Wi-Fi, radios, and other devices. So this is more important. That's because if the radiation is too high, engineer must to think how to add the protection, such as shielding or have the good grounding system, or must to add the filters in this equipment. So to make sure the equipment is user friendly. Okay, so the next activity is the conducted emission, electrical interference that travel through the wire or cable. Okay, the firstly is the electrical disturbance that do not travel through air. So what we understand of this point is, interference will focus on the electrical parts such as a power cable and metal connection. So the secondly is the interference flow through electrical parts such as power cable or metal connection. So that's point what I said earlier. This will use the power cable and the metal connection. And the thirdly is the human body is an electrical pathway and has a varying resistance. So in our group, before we start this activity, we have we have measured our body resistance members and get the height and weight of our groups. So that's because every human have the electrical parts. Everyone have the different body resistance. So when we touch the same metal plates, we will get the electrical current have flow the different result. Different result. So the last is the conductor emission depend on the current parts and impedance in the systems. So that show to us the conductor emission very depend the part of the current. That's why the rework electrical equipment need to be designed and test firstly properly, so the interference, the flow through the cable does not affect other equipment, and we will make sure they remain safe to use.
How to set up for radiated emission. So the first step, open trigger menu. Start by pressing the trigger menu button on the front panel to access the trigger setting. And then next, set mode and coupling. Change the mode to normal and set the coupling to AC. And then next, adjust channel 1 setting. Press the channel 1 menu button and the vote knob to adjust the scale until it's set to 1 volt. And then for the last step, set the trigger level. Turn the trigger level knob to match the channel scale, setting it to 1 volt. How to setting 30 volt on oscilloscope. So step 1, set the oscilloscope at channel 1, and then step 2, switch the volt in fine mode, and then step 3, go to probe and switch the attenuation to 10, and then step 4, change the voltage scale channel 1 to 30 volt. This slide show the radiated emission test result measured at distance from 4 to 20 meter. The purpose of the test is to evaluate to electromagnetic radiation produced by the system. And then from the table, the amplitude and pulse wave remain controlled and do not increase significantly as the distance change. The rise time and fall time are also consistent, indicating a stable signal. And for overall, the results show that the radiated emission are within acceptable limit, and the system complies with the basic electromagnetic emission requirement.
Okay, this slide is the original reading from our first experiment before any correction. We later found small error in the measurement setting. So in the next slide, we will show the corrected data with more accurate value.
So the radiated emission graph. This graph have the highest amplitude in voltage versus with the distance in centimeter. So for this graph, we will start with the 4 centimeter until 20 centimeter. So based on the graph, the general observed that the highest amplitude decrease as the distance between the radiation source and the ion plate increase. The highest amplitude was recorded at the distance 4 centimeters, has got the 61 volts, indicating that very close distance result in much stronger electromagnetic radiation exposure. So after we will win of this test, that show to us the close proximity has the potential to negative effect for the performance of our electrical device. So it's very important for engineer must to make sure they to make the design any new electronics equipment with the following the electromagnetic compatibility standards EMC. So compliance with EMC standards, we will get the enable safe and have the stable operation system even the equipment have the close distance with the any radiation.
So this table about correction of the presentation radiated emission results. The corrected data indicate a clear relationship between distance and signal strength. As the distance from the radiation source increase, the amplitude of radiated signal decrease. Following the inverse square law from 61.2 volt at 4 cm to 14.4 volt at 20 cm. Additionally, variation in rise time and pulse duration show that the signal become weaker and more distorted and greater distance. This confirms the electromagnetic energy reduce the intensity and stability as the propagates further from the source. This slide shows the simulation result for the correction of the precipitation radiated emission measure at 12 centimeter distance. From the data, the highest amplitude recorded is 26.4 volt with a rise time of 31.4 microsecond and the overall pulse duration of 34.8 microsecond. Okay, so the half wave is around 62.2 microsecond and the zero crossing time is 81.6 microsecond. This value indicate that this distance, the signal still maintain a strong amplitude but began to show line distorted compared to closer distance. In the conductor emission result, Zera had low resistance, 16 ohm, and produced a stronger signal of 3.44 volt, while iron higher resistance, 2 kilo ohm, with a weaker 2.08 volt signal. This show the lower body resistance allow more current flow, resulting in higher amplitude and stronger conductor emission. This slide shows the simulation result for the conductor emission using iron data. So for the peak amplitude is 2.08 volt with a 0.4 millisecond rise time and 248.8 millisecond pulse duration. The signal show the human body conduct electricity and variation in resistance or body size affect the emission stream.
For the conductor emission graph, highest amplitude in voltage versus name of our members, Zahira, Hazim, Adit, Kai, Raif, Yazid, Jai, and Ain, and Dani. So based on the graph, we have found that Hazim got the highest amplitude of around 3.84 volts, followed by Zahira, who also show have the higher amplitude reading compared to other members. For the lowest amplitude is around 1.6 volts. That's the name is Yazid, and the overall of the majority of the highest amplitude value is range in 1.8 volt to 2.5 volt. So why Hazim and Zahira have the highest amplitude is because before they get doing the testing of these activities, Hazim and Zahira have doing the physical activity in the farm, running in the one place in about 2 minutes. So that show the activity likely increase within and skin moisture, thus reducing skin resistance and allowing more electric current to flow. So for that situation, the amplitude reading have the higher other than members. Okay, so for the discussion, firstly the relative emission distance. The distance between the radiation source and the ion plate will affect the graph. So at the distance get the closure, the strength of the electromagnetic wave received by the ion plate become higher, and cause the reading of the graph will also increase. This standard EMC to avoid the interference with Wi-Fi, radios, or other electronic equipment. So we have the EMC standard. It will set to ensure that electronic equipment not produce excessive electromagnetic radiation. So all of the equipment must to follow the EMC standard. So the next is the conductor emission. The first is the human body. Difference in body water content, body size, and skin thickness cause the different readings. So we will understand what it is when the different individual touch of the plates, the electricity current flow will produce different reading and the waveform. So lastly is the noise electrical interference connected to the same system that can interfere with other equipment. This interference causes by the other equipment that shares the same power supply or electrical parts. So if not controlled, the noise will interfere with the operation of other equipment.
Okay, for the conclusion in this experiment, demonstrate that electromagnetic interference (EMI) can propagate either through air and radiated emission or through conductive parts such as cable and the human body and conducted emissions. The results show that radiated signal strength decrease with increased distance from the source, while conducted emission vary depending on the body resistance, height and width. This proves that the human body can act as a natural electrical conductor. Overall, the findings highlight the importance of control EMI through proper shielding, grounding, and filtering to ensure compliance with EMC standard and maintain reliable electronic system performance.